So we're going to look at law of sines when we know a side, side, and angle. It'll be kind of in that order. So let's say, for example, I know that angle B, let's start this off. If angle B is 70 degrees, side B is 15 inches, and side C is 3 inches, then find the missing angles and sides. Angles and sides. We'll say of this oblique triangle. Oblique triangle. Okay, so if we think about the law of sines, I don't know anything from the A ratio, but I do know from the B ratio. And let me jot down the formula I'm using. B over sine B equals C over sine C. So I'm taking those two ratios out of the law of sines and plugging in what I know. So, oh, and let's draw a triangle too before we get too far. Let's draw this out to see if it sounds about right. So I'm going to make angle B, say, right about there. That's 70 degrees. And then, let's say this goes a little farther. And something like this, because I want to make this 3 inches pretty small compared to the 5 inches across from angle B. So that means how I'm drawing this, angle C is down below to the right and angle A is to the left. Okay, so I'm going to plug in 15 for side B over sine 70. So side B over sine angle B. Side C is 3 over sine of angle C. Okay, so when I cross multiply, 15 sine C equals 3 times sine 70. Divide by 15. So sine C equals all of that. I could calculate right now. Let's see what that is as a decimal. 3 sine 70 divided by 15. If you're going to put this in your calculator all in one step, most calculators will start a parenthesis before the 70. Make sure you end it before you hit divided by 15. So you should get 0.187938. I'm going to keep quite a few. It's important to keep quite a few decimal points here to be accurate if you're going to re-enter this. Now otherwise, before you did that, you could have started off sine inverse, because whenever we want to find an angle, we have to do the inverse function. So sine inverse of this 0.187938. Or if we had started that, if we had started off that sine inverse before doing 3 sine 70 divided by 15, that would have worked too. Okay, so if I do sine inverse of that, yeah, I'm getting 10.8 degrees. So I'll go to the nearest tenth since we're at a pretty much like a final answer right now. I don't want. Okay. Okay, so I got angle C. So now I have both parts for B, side and angle, and both parts for C. So I'm left with A. So the first thing I can find, which will be a little more easy, is angle A. Because now I have the other two, I can take 180 minus 70 minus 10.8. And so angle A would be 99.2 degrees. So angle A is 99.2 degrees. So now that I have angle A, now I can use the A ratio. So A over sine of A, which I now know is 99.2, equals, now I really could use both ratios. It's a good idea. Just go back to the one we were originally given. 15 over sine 70. So now when I cross multiply, 15 sine, go away, 99.2 equals a sine 70. Divide by sine 70. So that'll get me side A. So 15 sine 99.2, I'm ending my parenthesis in my calculator, divided by sine of 70. So 15.76, we'll say. About 15 and 3/4. Which that, I mean, if we look at this, let's fill in our triangle. 15.76 inches for A being 99.2 and angle C being 10.8 degrees. That sounds about right. I mean, the 15 and the 15.76 are pretty close lengths, but 70 and 99 degrees are also pretty close, with 3 being so small. That seems reasonable that we would get those for our answers.